So, now we will see how the proportional control action will work, difference between that on off control and the proportional controller, and we will discuss and we will see how to implement the proportional controller using operational amplifier. So, in order to implement that, one thing we have to understand how exactly the proportional controller works. What is the relation between your input and output? Once we know the relation between the input and output, it is easy to develop or to design the circuit using an op amp. Now, so what is a proportional controller? So, the name itself says that, as we have also seen in a theory session, the proportional controller is nothing but the proportionate to that of your input. The input to the system is error and the output is always proportional to that of error. So, when we remove that proportional parameter, so that means the u of t is always equal to the proportionating factor K p, right, which is also called proportional sensitivity or the gain of the system into error of t. So, when we see, when we convert into Laplace transform and if you observe it, it looks something like the gain of the system. So, a proportional controller is nothing but a simple gain. So, proportional. So, that means depends upon the error factor, the output will be always proportionally change. How much proportionate it will change or what is the scaling factor entirely depends upon the K p parameter, that is a tuning parameter in this case. So, if your error is higher, right, the input voltage applied to the system, to the plant will also be higher. If the input is, the error is low, then the input, the output of the proportional control system, which is nothing but input to the plant, will always be low. So, that is entirely related to your error, right, error in this case input. So, that means how do we implement? So, when we recall, we can either use an inverting as well as a non-inverting amplifier with proper gain. So, that gain we can set by using your feedback resistance. So, by using a pot as a feedback resistor in inverting or non-inverting amplifier mode. So, this kind of a proportional action, control action can be easily implemented using op amp. Now, when we see, in order to realize how exactly the proportional controller works, this is a simple example similar to the previous one. In a previous case, we have seen that when the tank is almost at this position, right, then it will switch off. If it is higher than this value, it will switch off, and again if it is lower than this value, then it will switch on. You have only option like either completely on or completely off, but in this case it is entirely depends upon the level of your tank. If you see the animation very closely, so this is where we have connected our bob and this is where the valve, right. When the level is lower, there will be some flow of water into the tank or some liquid into the tank, and the amount of liquid flowing entirely depends upon the position of the bob. If the position is at the higher position, the output, the water in this case will be really smaller, into the tank is smaller, right. So, that entirely how much amount of water is being injected into the system entirely depends upon what is the level of your float. So, that means if I want to change the the gain of the system in mechanical way, so the position of this fulcrum decides, right, decides the band of your system. So, for example, if A and B are equal, right, the output, this offset is nothing but A by B into X, right. So, A by B is nothing but the gain. Now, what if the fulcrum is in this position? So, if it is in this position, the value of A is higher and the value is B is lower, as a result the gain is higher, right. So, that means if you want to understand, when the bob is at a low position, more amount of input, that means the valve will be completely open, right. So, more flow of water into the system, right. The band, if you see, it will be completely narrow. When the flow is keep on increasing, right, it will suddenly, there you can see a sudden close, sudden stop of your input, right. So, that means this error band entirely depends upon what is the gain, where exactly you are using the fulcrum. Whereas, if A is smaller and B is higher, the result the gain is very smaller, it takes a longer duration, which means that the band, the proportionality band will be even higher, right. So, the proportionality band entirely depends upon what is the gain that you are using it, or in order to understand what is the current, the rate at which the current flow into our system depends upon the gain. Higher the gain, higher current initially and slowly decreases, lower gain slowly it is, right. This is the way to just to understand the mechanical, but since in our case we have to understand about the electrical way, right. So, when we recall the input to the plant, input to the system, the control system is nothing but error, right, error signal, which is the difference between your measured input and your desired output, set point and the actual output. So, that difference input is connected to the Kp. If the error is higher, higher input will be given as an input to the plant. If the error is smaller, smaller input voltage will be given as an input to the plant, right. So, that means we require to use a simple gain amplifier, right. So, if you see, this is a simple gain amplifier that we are using. Now, in this case the first op amp A1, if you see, the gain of the plant is 1, and whereas the second op amp, if you see, right. So, the input to the first op amp is error signal. So, the gain of the system is 1. So, because of that we will get a negative output voltage here. Since we require the output to be in a positive condition, we require to use another operational amplifier configuration such that the output will be always in phase with your input signal too. So, in order to do that, since we are using inverting operational amplifier, we have to go with the 2 op amps. Either gain can be set here at this point or even at this point too, right, because the plant input range is only between 0 to 5 volts. So, in order to do that, we require to do some attenuation factor too, right. So, how do we understand this? The gain of the system entirely depends upon R6 by R5 in this case. Now, we have taken 10% of 10k, which is nothing but 1k, and R5 in this case is 10k. So, the gain is 1 by 10. So, another way of implementing a system is by using proportional and integral. So, if you understand, we are adding one more component into the system, which is nothing but integration. So, what is an advantage of having an integration? We have seen that with respect to the proportional controller, the output will be proportionately changes based upon the error input. If the error is higher, it will always higher. If the error is lower, the output will also be lower. But if the error is constant, as long as the error is constant, it will always maintain the constant, right. But some cases we require some intelligence into the system, meaning even though if I am applying some input voltage, but the error, the voltage, the output temperature is always constant, right. So, such a cases we require some intelligence saying that yes, since there is no response change in the output, I have to add little higher value input voltage. So, such an intelligence humans will always have, but when it comes to a system, how can you make that intelligence? So, that intelligence can be created by using an integration. So, if you recall your mathematics, what is an integration? How does an integration does? So, integration is nothing but area under curve. So, in this case it not only depends upon what is the present error, it depends upon the summation of your previous error, the accumulation of an error, right, that decides the manipulated variable in this case. Whereas, in case of a proportional controller, you do not have such an intelligence, it completely proportionate, input changing, error value is changing, output will change, right. What factor it is changing, what is the gain that you have set to the proportional controller, the same factor the output will change. But if there is an error between your input and output, and if the error is always constant, it cannot either pump higher value or lower value of the input voltage to the plant in order to reach to the required set point. So, because it does not have any intelligence. So, whereas in this case it will always count, it will always adds up. If the error is constant, the accumulation of error will be keep on increasing, as a result it changes your output voltage. So, as we have already seen in the theoretical explanation by professor, so just recall. So, if I say this is my threshold, sorry, this is my set point and this is how the output is keep on changing, right. keep on changing. When you do an integration, what it does is that it will adds up the error factor. So, the dashed lines is nothing but the error output, right. So, it adds up at this particular point, what is an error that I have. So, that sum is 135. Now, if it is keep on continuing, right. So, the error will be keep on accumulating, as a result the output will change. Suppose if it is at 60, so the integration sum will be minus 34 here and this is 135. So, the error is, so because in this case it is little higher compared to the set point, right. So, with 135 value, the quantity of 135, so it is going to more than the required set point. That means 135 is not an actual value. So, I have to decrease it. How much amount it is to be decreased? Entirely depends upon how much variation that we can observe here. So, as a result, the value that will be applied is 135 minus 134, sorry 34, which is somewhere around 101. But if I apply this 101, again there will be some undershoot. There is some overshoot here, there is an undershoot, and if I calculate, the error is 7. So, 101 plus 7. So, application of 108 quantity, it will maintain constant, right. In case of a proportional, if you realize, if the error is higher, the output will also higher, right. That means, if I say the error is this, output also this, error is smaller, output is smaller. It does not depends upon the accumulation of errors in case of our integration, right. So, that is the intelligence that we are creating. So, since we are using integrated in the system, the complexity of the system is also increasing, but how do we design? How do we design using an op amp? So, one thing we have to understand, using an op amps, any kind of operations that we can do. So, integration we can do, differentiation we can do. If you recall, the way of doing integration, by simply using of your resistor and a capacitor, it does an integration operation, and it is a combination of integration as well as proportional. We have to take an adder which adds with the proportional controller and which adds with the integral controller. The addition of these two is nothing but my PI controller. If I see the complete system, if you observe that the A portion of TL084, so TL084 is a quad op amp, so it has a 4 op amps inside. The A portion of TL084 first op amp has a gain of 1, so which is acting as a P, and if you see this B portion of TL084, a resistor and a capacitor, it acts as an integrator, right. I got P with a gain of 1 and I got integrator, and the factor, that the time factor entirely depends upon what is the resistor that we have chosen, right, which is nothing but 1 by RC, right. So, 1 by RC is the kg, which is nothing but the Ki, proportional integration gain, right. So, I have implemented using operational amplifier the proportional controller. Implementation of integrator using operational amplifier is done, but proportional controller is addition of P and I. So, we need to have an adder. So, this will have a negative phase shift, this will also have a negative phase shift. So, no problem. So, I am taking a negative adder, right, I am taking a negative adder. So, the output will be positive. So, what it does, if I say this is V1, V02, V03 will be minus of R6 by R4, since both are same resistance value, it will be the gain is 1, minus of minus V01 minus V02. So, which is nothing but V01 plus V02. So, we are getting a gain, we are getting V03 as the required PI controller output, but what is the value it will be? The value will be entirely depends upon what is the gain that we are setting here, what is the value of this, right. So, the addition of these two will be some other value, but is this voltage is good enough to pump my give as an input to the plant? May not be. Sometimes the output will be even at more than 10 volts, but I require the voltage, the range of the input voltage to be given as 0 to 5 volts for the plant. So, in order to maintain that range, we are using one more operational amplifier, right, which attenuates. When you see, the gain of the system is 1 by 100 in this case. Okay. So, which will attenuate that, right. So, the proportional gain is 1, the integral gain is 1 by 100, right. So, the overall gain of the system is 10 by 100, which is 0.1, because so overall gain, if I want to calculate V naught by VO3, right. So, this gain is 0.1. So, compared to the voltage whatever we get, it will always multiply with a factor of 0.1. So, that even if the input voltage is somewhere around 10 volts, it will be at 1 volt. So, which will match to the plant requirement. What about the phase? If you see, when you observe the error, right, the error will be always. So, let us take this is the input, this is set point 60, 60 minus 50, 10, right. When the input is 10, this will give minus, this will give minus, this will give positive, but again this gives negative, but we require a positive. That means, we have to use one more operational amplifier which converts, which will always maintain the same phase, or rather than using a simple inverting configuration, we have to go with a non-inverting configuration with the same R7 as a pot. So, that the required gain can be set by using R7 resistor.